Hey guys, welcome to my channel. In this video I'm going to talk about the queue data structure. So before watching this video you have to watch arrays data structures and stack data structure. In those videos I explain briefly how those data structure work, and it is stack is very close to the queue. So if you want to understand queue better, you need to know stack data structure as well. So that is the very important thing. So queue is very simple. It has two important things, which is front and it has rear. And the front is the value that you add first. Suppose I am adding 1 at the beginning, okay, then I have 2, then 3, and then 4. Now 4 is our rear and 1 is our front. So at first I added 1 here, then 2, 3 and 4. So what is the order? First I added this one, then this one and this one and this one. So we are adding element at the rear. When we add some element, our rear would be incremented. Okay, when we add some element in this queue data structure. But when you remove some element or pop some element, this one would be incremented. Suppose 1 is removed or 1 is dequeued, we call it dequeue. The same as pop method in the stack data structure. The dequeue is just pop the element. Okay, so when we pop 1, this place would be empty, and then we have 2, 3 and 4 left. So 1 is gone. This is dequeued. So this is just become now the garbage value. So we are incrementing front from this position to this position. This is 0 position, this is 1 position. Okay, so we are incrementing the front in case of dequeue. Okay, but when we add element, we just suppose add 5 here, this 5. Now this value would go there. Our rear is this one. Okay, our rear is this one. So from this position to this position we are adding an element. Our rear is this one. So our rear is incremented. So remember that when you add element, you have your rear would be incremented in the queue data structure, and when you dequeue some element from the queue data structure, and your front would be incremented. So this is the two important things that you have to know. So this is simple. When you are ticketing a bus ticket, when you are waiting for a bus ticket, when your friend come faster, he will take the ticket faster than you, then another person, then another person. So it is called first in first out. Whoever comes first will get the ticket first or get the job done, then second one, then third one. So that's why the 1 comes first. So if we want to dequeue some element, 1 would be dequeued first, then 2, then 3 and then 4. And when to add element, it would be add in the last part, which is rear. So this is the main thing that you have to understand. Let's go to the coding part. So now we're gonna see the practical part of our queue data structure. So let's go to our code blocks where we run all of our C code. Go to file and new and empty file, and Control S and name it QYT. Okay, and save. Now let me bigger it by using the control and mouse ruler. So as usual I need to write hash include stdio.h, the standard library that we have. Then we need to define the maximum size of our queue using hash define queue underscore size, which is 10. Okay, so our maximum queue size is 10. Then we need to write integer main function, but we'll keep it as like this simple because we're going to work in the main function later. Let's make the structures of our queue data structure. It is simply like the stack data structure that you have watched. It is simply like that, and queue and stack are same in some type of thing. So you need to watch both the videos to understand it perfectly. So let's make a structure of queue data structure. So how you can do that in C? By using type def, okay, and struct. So by writing this we can make a structure of our own in queue data structure. So in queue data structure we have integer front and rear, and in our main data structure we're gonna hold the maximum size, which is queue underscore size that we have defined here. So our main structure is defined, which is one we have front, and another is for holding rear, and another is for our data structure where we hold the maximum size of the queue size, which is 10. Okay, so our structure is done, and all of this structure is a queue data structure. Okay, so I write queue here. So now we need to put some values in our queue data structure. For that we need to write a void function, void enqueue. Remember that in the data structure this is actually the push function, that how we can add some element, and the enqueue in for queue data structure we use the enqueue to add some element. So it will use our queue data structure from here. So this queue is actually pointing to this queue data structure. Okay, and we are using pointer to point our main data structure that is pointing here. Okay, so this s represents our queue data structure, but for this tag I have used s, but in queue you can use its own personal variable called queue. So this queue is actually pointing to this queue, and this queue is pointing to this queue. Okay, and we need to add some item which is integer type, this item. So let's write the logic. First we need to check if it is empty or not. If it is full, if our queue is full, then we cannot add any item. So what is the logic for the full, which is if queue rare, so this rare is coming from this rare, if rare is equals to our queue size, then we cannot add element. So it means that our rare is equals to the queue size. Rare is actually the last position of our queue data structure. If it is equals to our maximum size, that we cannot add some element, it would be full. So we need to write printf queue is full. Okay, simple. And you can also do return 0 for that. Else, so in this case you can write the logic to add the element. Now what element you will add? This element item on the queue data structure. So first we need to write queue data. In this data structure we want to add at which position? At queue rare position. So when to add some element, we need to add the element in the rare position. So this queue rare is actually the positional value in the rare. So in the rare value, so in the rare position of the queue, we are adding the element in this queue data structure. So which element? This element, the item that is passed in the function. So this item would be added on the queue rare. It means in the last position of our queue data structure, that is holding the rare, and in the last position we are adding the item in our queue data structure. So after that you need to increment your rare. So your rare have got one more item, so we need to increase it and increment it more, so that the rare goes into the last position, because rare is always at the last position of our queue data structure. So we need to increment it. So queue rare would be queue rare plus 1. Okay, just increment it and it is done. So this is our enqueue function. Always remember that this enqueue function is a void type. It does not return anything. So after that we need to write a function which is dequeue, which popped some element from the queue. Okay, so in which queue we want to dequeue element. So this would be queue of pointer queue. So from this queue we want to pop some element or pop some item, and in pop we can say in queue it is dequeue, actually the popping. Okay, so when we want to dequeue some element, we need to check if it has some element in it. So for that the logic should be, let me first write the item that we want to return in integer value, and then we like to write the logic if it is full or not, or if it has, and then we need to check if it has some values or not. So if queue rare is equals to queue of front, so it means that your queue front and rear are both the same. It means that there is only one value in the queue. Okay, so you can write printf there is only one value in the queue. Okay, in else if part you can write another logic. If queue rare and queue front is equals to -1, it means that your q front and q rear is equals to -1. It means that there is no value. Okay, so printf, you can write no values. It will just return -1. Simple. In else case, you just write the main logic to dequeue some element. So how can you dequeue some element? It is very simple. In the item, we will hold the queue data structure, and how can you dequeue? From the front. Okay, so from the front we want to dequeue, so it should be queue front. Okay, so from the structure of our queue data structure, we are just taking the position of our queue front at which value is stored in the queue front, and just returning that value in the item variable. So simple it is. And then we need to increment our front so that we can go further. We need now our front is changed to its next element, so you need to write queue front is equals to queue front plus 1. Simple. And then we just need to return the item that we get. So this function is a return type. It is integer type returning. Okay, so this item is an integer value, that's why it is integer dequeue. I need to write the integer main function. Okay, so in the main function, you need to write integer item that we will get, and then our queue data structures, and we name it like my underscore queue. Okay, so our queue is a variable of my queue. We can understand our main queue data structure by calling this variable. Okay, which is type of queue data structure. So our item is for holding our item that will be returning, and this queue is for knowing that this is the variable for the queue. Okay, then let's point as my queue dot front is equals to 0, and my queue dot rear is equals to 0. It means that there is only one element in the queue, which is 0. Now as there is no other elements other than 0, and our size is suppose 10 here, so we can add more elements in the queue. So now it's perfect time to put some value. So it is in queue at which, at that's why you need to add ampersand, which is my queue. So in my queue, and this ampersand is for telling that we are pointing to this queue. Okay, the holding the address of this queue. In this queue, I need to add some element, which is 10. I want to add 10 in this queue. This is actually the item, which item is coming from this function, the queue and this item function. So this is the parameters that we are having, which is integer item, and at which queue and this queue. Okay, so we are pointing to this queue using the ampersand to point this queue, and we want to add 10 values in this. Okay, so let me write this for, so we need to write printf, say let's print this tail is equals to %d/n for the next line, and we will print my queue dot rear. Okay, because rear would be increased when you want to add some element in the n queue, our rear would be increased, and we want to print the rear. So let's just copy and paste this 4 times, 2 3 4, so total 4. We are adding first 10 and then 20 and then 30 and then 40. So all the values are added in the queue data structure. Then it's perfect time to dequeue all the element that we get, which is item is equals to dequeue, and we want to dequeue from which, ampersand my queue. So from my queue, I want to dequeue the items here. So first we added 10, then 20, then 30, then 40. So when you dequeue, it will dequeue first 10, then 20, then 30, then 40. So let's print this and see the result. Item. So let's just copy and paste this more 3 times. Let's just so that's all the code that we want to share. So when you just build and run this application, you're gonna see first we have 10, then we have 20, then we have 30 and 40. So why it is printed this way? Because we added this in this way, 10, 20, 30 and 40. But in this stack, the last element would be printed first. For that it would be 40, then 30, then 20 and 10. But in this architecture of queue data structure, the first element is added, would be displayed and dequeued first. So we are seeing 10 first, then 20, then 30 and 40, and whichever element is added in the last is showing on the last. Just like the station where we want to buy ticket, or so when we go to the last position we get the ticket at the last, but when we get at the first position we get the ticket firstly. So it is first in first out. So we added 10 first, it is added 10, and then 20, then 30 and then 40. So that is all the things that you need to understand as for the practical coding of queue data structure. So in the next video I'm going to talk about trees and different kind of trees and how you can code the structures of this, and the linked list as well. So all the data structure would be covered. So thanks for watching guys. I'll be coming with a lot of exciting videos. So thanks for watching. I'll be coming in the next part where I'll talk about tree data structures and linked list. So thanks for watching. Till then, take care. Bye bye.